Basically we take sheep's wool not directly off the back of the sheep, but it's shorn off the sheep. It's given into the British Wool Marketing Board, who then sell the products to us, and we then process it by taking the wool and washing it, or scouring, the process is called, where you take out the lanolin and the dirt from the actual fleece itself. It's then processed through what they call a direct collection line, which basically builds up the thicknesses of insulation that we require. We add a polyester binder, a very small quantity of polyester, to the material to actually bind the fibres together. And then the products are basically produced in either a slab format or a roll-based format, which is called PB20. The real difference between the two products are, one is 85% pure wool, which is the slab-based thermofleece product, whereas the PB20 is made from recycled polyester and sheep's wool of a 60-40 type of split. And the reason for the recycled polyester in the PB20 is because it's a tightly wrapped roll to 60% compression. We need to ensure that when the product comes out of this compressed state, it actually recovers to the required thicknesses so that you get full utilisation of the fleece itself. So the polyester binder, or the recycled polyester content, is to act as what they call a lofting agent, that basically when you screw the fibre up, it springs back to required. It doesn't affect the thermal performance at all, or the actual naturals, because it's a recycled product. It's basically part of the system to make sure that what we say thicknesses are achievable on site. Most people think of natural insulations as being not as good an insulation value as the competitive man-made fibres are. That's not true. In most cases, rock fibre, glass fibre has a poorer insulation value than sheep's wool has, by some degree, some 10 to 12% poorer thermal efficiency. Therefore, when you buy in these products, particularly in relation to a higher insulation value, you've got to ensure that what they call K value or lambda value is of a degree that matches the performance you're trying to achieve. So it's very critical that when you look at thickness, you also look at the insulation value that that thickness is going to give you, to make sure you're looking at like for like. So the one benefit is the material is a lot better thermally than most people would normally think of a natural fibre should be. The second benefits really relate to the usability. It's extremely soft to handle, non-irritant. You don't have to get dressed up in spacesuits to actually install the product. For the smaller user, the DIYer, this can be quite a nuisance factor. With the wool-based material, it is extremely soft to handle and to work with. Technically also, when you are looking at problems such as asthmatic reasons, we in the market are generating lots of what they call formaldehyde-based products, glues, foams, chemicals, which are used to treat fabrics, finishings, furnishings in buildings, give off formaldehydes. Formaldehydes are a carcinogenic. What happens is that the fleece, the wool, locks that formaldehyde into the fabric of the actual material and stays there for the whole life of the building. So again, it's acting as a natural filtration system which protects you as the occupant as well as the actual building physics. And probably one of the other unknown factors about wool insulation, which is as important if not more important, is that it's a renewable material. Each year the sheep grows the wool, each year it is shaved, each year it's plentiful. Therefore it's not going to run out. We're not taking natural resources out of the actual planet. We're just using what's naturally coming and locking in carbon in the process at the same time. Return on investment can be arguable of the lifetime of the building, and most buildings should be measured on that basis. We tend to, in this country, work on today's price, today's cost. But when you look at things like the thermofleece materials, you're talking about a product which is BBA approved and has been given a guarantee as lifetime of the building. and that means that this product won't decrease in thickness, won't lose its insulation performance over the lifetime of the building. Subsequently, if you look at other man-made fibres, glass or rock-based products, they will be often replaced or topped up 3-4 times in the lifetime of the building. So what may look expensive at the start of a project, in 60 years' time is then very inexpensive, because you probably had to replace your existing materials twice, if not 3 or 4 times. And also with building standards changing, this is quite a critical factor. You don't have to keep on topping up your insulation. It's already there at the thicknesses you purchased at. Eden Block has been developed as an alternative to the petrochemical-based insulation rigid board materials, predominantly the polystyrene type of products. The market is dominated for what they call lining systems by poor quality, low cost polyurethanes, polyisocyanate type of products. These are used commonly just to increase the insulation standards within a building, whereas they're non-natural. They are earth-depleting resources, oil-based systems. Using the Eden Block, which is made from carpet waste, sheep's wool, and ground together, made into a rigid insulation material, it actually gives you an alternative with an extremely low insulation value to compete with these type of products, and is very useful in the dry lining market as an alternative.